Hey everybody, Mr. Reed here. And up to now, we've been exploring the different drug resistance that shows up in our parasites and how our different drugs have different cause and effect relationships with our three different criteria. We're going to dive a little deeper into this as we look to understand that cause and effect relationship a little bit more. And we're going to be looking at how to read our histograms that we've seen in our last task from our article. So we're going to be looking at those two things. Make sure when you come back to our survey here, you reach out if you put your X in yellow or red. So in our reading, you came across this histogram, which shows the malaria parasite population. Now, this data came from scientists collecting the number of different resilient types found to each of our drugs within our parasite population. So, for example, for our resilience to drug A, we see that 90% of them have no resilience to drug A. Those would be all of the parasites that don't have any red bars in them. So, everything without a red bar does not have a resilience to red. Some of them, 10%, have a resilience. That's where we see the 1%, and 0 have high. As for our resilience to drug B, if we look at that, that would be like all of the parasites that we see with the bar without any bars and with any bars that have red in them. So those are all the ones with no resistance to drug B. We have a 40% with some, so that would be the ones with the blue lines that we see here, the one blue lines, and then we have 20% with high, that would be the two blue lines. So scientists collected this data before we used our different drugs to see what was the parasite's traits like before we use our drugs. And this is what our patients' malaria population would look like for their parasites. Now, these histograms are used to show the resilience levels before treatment. When we dive into our simulator, we're able to look at those histograms and see what is the cause and effect between those drugs that we use. So we look at the we look at the traits in our parasites before. We would toggle over to the right to see the effects of those drugs after. If you notice, we see those different changes in those histograms. And today we're going to look at how we read those different histograms. So let's take a look. If you remember from a while ago, we played a game where we had different parasites that we would roll dice for to see how their populations would change. And these would be our little parasites, and we would collect data on how many of them are resilient to all the different drugs. So if you notice here, we have a set of histograms that show what our parasites look like before a single drug treatment using drug A. We would count the different types of resistance, and we put them in our makeshift histogram here. If we were to apply a drug, for example, the red drug, we would see a difference in the overall resilience levels after we applied that drug. We would see a different resilience levels not only to the red drug, but also a different resilience level to the blue drug. Our population here has very unique resilience levels for red and blue, and when we apply that red drug, we're able to see some of those changes. So biomedical engineers will collect this data in these histograms so that they can record what's going on in our population. When we apply these different drugs to our populations, we can see the cause and effect in how the traits change. Different resilient level traits are affected in different ways by the drugs. So we're going to look at how that works. Now, we're going to take these different histograms that we just looked at, and we're going to turn them into some histograms where we can see the different percentages of our different traits. So when we look at these histograms, please know that these are the same histograms that we just looked at before. We see that before we had our drug treatment, we have 17% of them have high resilience and the rest have none. After we applied the drug, we see it has changed. With that same population, we had a certain number that had no resilience to the blue drug. 17% had a high resistance to the blue drug. And if you notice here, we have a new set of traits found after we apply the red drug. Remember, we are applying our red drug. Now, We can take the data we collected and turn it into these histograms. And when we do, we see a few things. Number one, the parasites with the high resistance to red, that number went up when we used the red drug. Kind of counterintuitive. The parasites with no resilience to the red drug kind of went down. Now, the parasites with high resistance to blue we see here all went down, whereas the parasites with some resilience went down as well, and those with none actually went up. So when we compare the two for red using the red drug, and when we compare the two with the blue using the red drug, we can conclude the following. Different drugs help us lower the resilience levels to other drugs. So red helps us lower the resilience level to blue in this case. But it can lead to high resilience with the drugs that you apply it to. So notice, red caused the blue resilience to go down to 0, but red made the high resilience level go up for red. So when we collect our data, it's easy to see that cause and effect relationship. Now, these histograms that we see here that we just looked at and analyzed are the same histograms that we have in our simulator. So what we just did here is how we would analyze the histograms in our simulator. So your job is going to be now to see what happens when we apply a blue drug to that same starting population. You're going to be given this histogram, which is just a representation of our biomedical engineers collecting that data, and it's your job to analyze it. And what you're going to be looking to analyze is, do we see the same cause and effect relationship when we apply the blue drug now to our population? So you're going to see this histogram where we have our red and blue starting population. We're going to apply our blue drug. Do we see those same ideas showing up with this population? So that's how our cause and effect relationship works. That's how we read our new histograms. Reach out if you need help. Otherwise, good luck.